Hello Senior 1 students, this is Mr. Karim Rashad, and in this video we will talk about classification of acids and bases. Number 1, acids. Acids can be classified according to number 1, their strength, number 2, their sources, number 3, basicity. Number 1, we will talk about the strength of acids. Acids classified according to degree of ionization into strong acids and weak acids. Strong acids are completely ionized in water, but weak acids are not completely ionized in water. Just like strong acids like hydrochloric acid, sulfuric acid, nitric acid, weak acids like all organic acids such as lactic acid, acetic acid, and the carbonic acid, phosphoric acid, hydrofluoric acid. Number 2, classification of acids according to their sources. We have mineral acids and organic acids. And the source mean from where the acid comes from, organic origin or not organic origin or inorganic origin. Mineral acids, they are acids that have non-metallic element in their composition, just like hydrochloric acid, nitric acid, sulfuric acid, phosphoric acid. Organic acids, they have an organic origin. That means they are extracted from plant or animal, just like acetic acid, it's found in vinegar, citric acid, it's found in lemon, lactic acid, found in milk, formic acid in ants. Number 3, classification of acids according to basicity. We have 3 types of acids: monobasic acid, dibasic acid, tribasic acid. Monobasic acid, they are acids that dissolve in water given one proton, one H positive, like hydrochloric acid, nitric acid, like formic acid, acetic acid. Dibasic acids, they are acids when dissolved in water, they give 2 protons, like oxalic acids. Tribasic acids, they are acids when dissolved in water, they give 3 protons, like phosphoric acid, H3PO4. When it dissolves in water, it gives or it produces 3 hydrogen ions. Now we will talk about bases. Number 1, we will classify bases according to strength. We have strong bases and weak bases. Strong bases, they are completely ionized in water, and also they are good conductors of electricity, like sodium hydroxide, potassium hydroxide. And weak bases, they are partially ionized in water, and also they are bad conductors of electricity, like ammonium hydroxide, lead hydroxide, ferric hydroxide. Classification of bases according to structure. Number 1, we have metal oxide, just like calcium oxide, magnesium oxide. Number 2, we have metal hydroxide, like calcium hydroxide, sodium hydroxide. Number 3, we have metal carbonate, sodium carbonate. Number 4, we have metal bicarbonate, sodium bicarbonate, and all of them are considered bases. And when metal oxides react with acids, they produce salt plus water, like iron oxide plus hydrochloric acid, it gives iron chloride or ferrous chloride plus water. Number 2, when metal hydroxides react with acids, they produce salt plus water, like calcium hydroxide plus sulfuric acid, they produce calcium sulfate plus water. And metal carbonates or even metal bicarbonates, when they react with acids, they produce salt, water, and carbon dioxide, like potassium carbonate plus hydrochloric acid it gives potassium chloride plus water and carbon dioxide gas. After that we have how to detect an acid or base, or how to know the substance we have it's an acid or a base. We have two ways. Number one, we use indicators. Number two, by hydrogen exponent. But first, what are indicators? Indicators or detectors are weak organic acids or bases, and they change their colors according to the medium or according to the solution. We have number one, methyl orange. Methyl orange, it's a substance when we put it in acid, its color becomes red, and when we put methyl orange in a base or alkaline medium, its color becomes yellow, and when we put methyl orange in a neutral medium like pure water, its color becomes orange. Number two, phenolphthalein. When we add phenolphthalein into an acid, its color will be colorless. Colorless means like the color of water. Its color doesn't change. It will be like the color of water. And when we add phenolphthalein to an alkaline medium, its color will be pink. For example, litmus solution or litmus paper. When we add litmus paper to an acidic medium, its color will be red, and when we add litmus paper to alkaline medium, its color will be blue. Okay. After that we have pH meter. Here we have three types of solutions. Number one, acidic solution, and it's a solution contains more hydrogen ions, so pH is less than 7. Number two, neutral solution, and it's a solution contains an equal numbers of hydrogen ions and hydroxide ions, so its pH will be equal 7. Number three, basic solution. It's a solution contains more hydroxide ions, so its pH will be more than 7. After that we have salts, and salts are formed when hydrogen ions of an acid are completely or partially replaced by a positive ion, and salts found in Earth's crust or found dissolved in sea water. How to form salts? We have four ways to form a salt. Number one, reaction of metal with acid, like zinc plus sulfuric acid. It gives zinc sulfate, which is salt plus hydrogen gas that evolves. Number two, reaction of metal oxide with acid, like copper oxide plus sulfuric acid. It gives a copper sulfate plus water. Number three, reaction of metal hydroxide with an acid, like sodium hydroxide plus hydrochloric acid gives sodium chloride, which is salt plus water. Number four, reaction of metal carbonate or bicarbonate with acid, like sodium carbonate plus hydrochloric acid. It gives sodium chloride, which is an acid, plus water plus carbon dioxide. After that, nomenclature of salts, or how can we name a salt. Any salt consists of two parts. Number one, cation. Number two, anion. And cation is a positive ion, and it's written on the left, and anion, it's a negative ion and written on the right. And the first part or the first term of salt describes the positive ion of a base, and the second term or the second part describes the negative ion of acid. And here we have some examples of salts, like potassium nitrate, KNO3. It It comes from the anion nitrate NO3 negative and lead nitrate PbNO3 by 2. It comes from the anion nitrate NO3 negative, like sodium chloride NaCl. It comes from the anion Cl negative, potassium acetate CH3COOK. It comes from the anion acetate CH3COO negative, sodium sulfate Na2SO4. It comes from the anion sulfate SO4 negative 2, sodium carbonate Na2CO4. It comes from the anion carbonate CO3 CO3 negative 2. And salts may be acidic or basic or neutral according to the acid and the base that reacted together to form salt. For example, if we have a strong base plus strong acid, the salt will be neutral. And if we have weak base plus weak acid, the salt will be also neutral. But if we have a strong base plus weak acid, the salt will be basic. And if we have weak base plus a strong acid, the salt will be acidic. Thank you, Senior 1 students.